Let's draw the Lewis structure for ethanoic acid found in vinegar, also known as acetic acid. We're told we have the molecular formula here, but we're actually given the structural formula. It tells you how these things are connected. When you see a CH3, that is a methyl group, and those are nonpolar. And you might recognize this COOH from biology when we learned about amino acids. That is your carboxyl group. Of the amino acids, they have that, and let's assume you don't remember any of that. Put the carbons in the center because they're the least electronegative. One side is going to get that CH3 is going to be that side, so let's connect that. Got to connect the carbons, and then the other side is going to have the one oxygen with a double bond to the carbon, and then another oxygen. This, by the way, is called the hydroxyl group. Now, I almost forgot the lone pairs. So these oxygens have a lone pair. So if you, let's do it that way. You may have had to finagle around a little bit with the formal charges, but ultimately you would get something like this, where all the atoms have a formal charge of 0. Now let's answer part B. Is the bonding between each of the atoms and the carbon the same? No. One of the carbon-oxygen bonds is a single bond, so that is a sigma bond there, by the way. These are all sigma bonds. They're all single bonds or sigma bonds, and this one has a sigma bond, but also has a second bond, the double bond, and that is the pi bond. That's from the side-to-side overlap of the unhybridized p orbitals. To answer that simply, you could say one of the bonds is a single and the other one is a double bond, or you can just say no because it's a yes or no question. Now, part C is asking us, is the bonding between the carbon atom and each of the oxygen atoms polar or nonpolar? All right, so I'm back here with the electronegativity difference between a carbon and hydrogen, that we call that delta chi, is 1. That's a polar bond, so these bonds are polar. So this bond is not equally shared. The oxygen is going to have a partial negative charge, and you got the same thing over here. Now this one I need to redraw so it's a little bit easier to see. Okay, so I just redrew this part here, so it's a little bit easier to see. So this is a polar bond. This can participate in hydrogen bonds. The difference between the oxygen and the hydrogen is 1.4. It's even more polar. So that is, yes, the bonds are polar. Let's move on to the last part. D, is the molecule polar? Yes. This side is nonpolar, but the molecule as a whole is polar because it has this side.